reverse distribute or reverse FOIL. In this case, we're introducing the negative term here, and so first of all, as always, we pull out any common factor for the three terms together, and we can see there is a let's see, common factor of 6 in all three terms. So we would first factor out that 6, and then we would ask the same question we have been asking. What two numbers can we multiply together to get 42 and add them together and get a 1? This would be a 1 here. Well, now we know that in order for the product to be negative, one of the factors of 42 has to be positive and one will have to be negative. So let's think about that over here. Factors of 42. 1 and 42, 2 and 21, 3 and 14. Oh, 6 and 7. Now the difference between 6 and 7 is 1. So for one of these to be negative and one of these to be positive, let's see. We need a positive 1. Well, that means the 6 has to be the one that's negative. So we write negative 6p plus 7p, and that will give us a total of 1p, like this. And their product, 6 times 7, is 42 with the negative. Continuing on then, we group the terms, first two, and we can factor out a p, like we did here, and then we group the second two, and we can factor out a 7, we did there. Then we combine, like we did before, the p minus 6 term is multiplied by p and by 7. So we're almost done, but we don't want to forget about this 6 that we factored out at the beginning. And there it is. Our next example, we have a negative 50. That means we're going to be multiplying a negative and a positive. So first of all, we check for common factor, and we see we have a 5 again. So we'll factor out that 5. And then we have to find two numbers that when we multiply them together we get a 10, but when we add them we get a 3. One of them is positive, one of them is negative. Get a negative 10. One of these is positive and one of these is negative. Well, let's see. In order to get a 3, a positive 3, that would be a negative 2 and a positive 5. So then we write the next thing we do is write this as a minus 2 and a plus 5. So here I show the minus 2k and the plus 5k. And continuing on with our factoring process, we group the first two terms and we find that we can factor out a k. Right there. Factor out a k. Then the second pair of terms, we see we can factor out a 5. So we factor out a 5. Then we continue to combine the terms. K goes there, and we also distributed a 5 onto the k minus 2. And we don't forget the 5 we factored out to begin with, and there's the final product. Now the next one's a little bit different, where the last term is positive, but look, there's a negative right there. The only way to get a positive here, the product of two positives or the product of two negatives. Well, if we have two positives, this negative isn't going to appear, and if we have two negatives, that would work. So that's what's going to happen. We're going to end up with two negative numbers, the product of two negative numbers to give us a positive. But first, as always, we check to see what we can factor out. We have a common factor of 3 and also a y. So we would factor out the 3 and the y. And then we would start asking the question, what two numbers can we multiply together to get 5 and add them together to get 6? And the 6 is negative. Well, The only way to do that is a negative 1 times a negative 5. And so then we break up the 6 to a negative 5 and a negative 1x. Pulling out the common factor from the two first terms, that's an x, and then the next two terms, well, there is no common factor for these, so we just pull out a 1. The problem with that, though, is look, here we have an x minus 5, and here we have a minus x and a plus 5. These signs are backwards from these signs. Positive, negative, negative, positive. The way we can compensate for that is to, instead of adding 1, make it negative 1. Distributing the negative, then we would get the same equivalent. Plus this is the same as minus that. So once we switch those signs around, then we have the same term we can factor out, and we bring down the 3, and we get our final factored form. There it is.